And now it's time for the latest exciting episode of Doz's Television Workshop.
Hello and welcome back to Doz's Television Workshop, where today we're going to be looking at this Manley dual mono microphone preamplifier, proudly designed by David Manley and handcrafted in Chino, California. It's a rack-mounted studio piece of kit, very nicely made. We've got a little ding on the corner and that, but other than that it looks in very, very good condition indeed. And it does apparently work, but the gentleman in question would like it checked out as he wishes to sell it, and he wouldn't want to sell anybody something that's not on the money. So yeah, let's just have a little look at the front panel. Each we've got two identical channels. We've got 48 volt phantom power for condenser microphones. We've got two input attenuators here. We've got an overall gain switch here. And we've got two sort of phase change switches here, and of course mains on off on the other end. On the rear panel we've got a mains input connector, just the usual IEC kind of thing, fuse holder. Now this is good. We've got a circuit ground and a chassis ground with a little link in between, so if you do get a hum issue, presumably you can take that off. I believe that's covering a transistor, but it's proudly stating upon it, approved for electrical safety, City of Los Angeles. There you go, balanced outputs, unbalanced outputs, and two microphone inputs there, on XLRs of course. Right, okay, now the only thing that worries me is, being American, it doesn't state anywhere what voltage it's expecting to receive, but it's okay because we've got a manual for the thing. Mains connections, page 4. So let's just go and have a look at that. Introduction, blah 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 blah. Page 4, mains connections. Your preamplifier has been factory set to the correct mains voltage for your country. Depends where it was bought, really, isn't it? I don't know if this was imported or not. The voltage setting is marked on the serial badge located on the back panel, on the rear panel. Check this complies with your local supply. So local in this country is sort of 220 volts harmonized, 50 hertz. The worrying thing is this serial number on the rear here was clearly written in some kind of marker pen that over the years has faded. I may make a telephone call to the owner and just check it's 240 volts, unless it becomes blindingly obvious when we take the lid off. The construction, by the way, is quite good. We've got just a perforated bottom and a perforated top, and I don't know whether this is picking this up on the camera. Can you see there's sort of a halo mark there, there, there and there, and if you sort of see through, in fact I think it's coming out better on the camera than it is in real life. I think you just see underneath there, that's the heat that's been coming off those little valves. A gentleman that owns this also expressed concern that he wondered if the valves had it, because there is a thing in the manual, and there is indeed, that says change the valves every 5 years. But let's have a look at that in a second. Oh wow. Okay. How beautifully made is that? Yeah, that's really quite nice. We've got quite a substantial power supply section, all screened off with steel supports from the transformer and the microphone section itself. The inputs and outputs appear to be transformer coupled. Looks like that capacitor was a bit of an afterthought, doesn't it? But it's all looking in beautiful condition, and it's all looking very nice indeed. He did say there was the odd pop from it every now and again, and I just wonder whether maybe some dry joints or just grubby pins on the tube sockets. let's just have a little look at the tube lineup. I was expecting to see sort of a couple of ECC 83s or something in here, but we haven't. We have got a 6414 made in the USA. National brand. Those pins aren't looking the cleanest in the world, so that's probably the source of our popping and crackling actually. Looks like that capacitor was a bit of an afterthought on each channel as well. Not expertly soldered on there. They've made a right mess of the insulation. So we've got a 6414, which I have to say I don't really recognise. And oh yeah, there it is, a 12AX7, and that's a Sovtech tube, but it has the Edicron logo on it, which I thought was a British manufacturer, but that's actually a Sovtech tube. I happen to rate the Sovtech 12AX7, although I'd gone for the 12AX7 LPS if it was for me. They tend to be a little bit more robust. Then again, this isn't like a guitar amp where it's getting lugged about between gigs, is it? If it just normally sits in a rack. There we go. So let us work out how this is wired up. So we're on 234 volts. Look, you can quite clearly see on the transformer there that marking is for 234 volts. So the transformer's actually mounted off the chassis on sort of like L brackets here. Very nicely done, I must say. We appear to have some sort of transistorized, stabilized rail there as well. What have we got? 15 volts there. So I suspect all the heaters may be wound for 12 volts, and that's what that's stabilizing over there. 35 volts, which doesn't appear to be doing anything, and 275 volts HT, which will be divided down by these resistors for a super smooth HT rail, I'd imagine. Right, so I think the first thing to do is let's just inspect for dry joints, and I can in fact see a wicked one straight away. Let me zoom in from the top if I can. There. And there are a couple of savage joints I will just point out there and there. It's on that capacitor there, I think. But that is as dry as a bone. That's horrible. It's not much better on this channel over here, actually. That's probably the cause of the random pops and crackles in there. So let's just warm an iron up and solder those up. My word, I don't think this lead is even soldered in, and it's got that wicked heat damage on it. Just makes you wonder if somebody sort of modified this and wasn't very adept with an iron, because that doesn't even look soldered up. I'm just going to put a dab of flux on there. So this should make lots of lovely smoke. And you can't see any of that because I've zoomed out too far. There we are. That's much better. That capacitor appears to be soldered directly across this little one here. So I wonder whether it was to give it a little bit more low frequency response perhaps. But yeah, again, these joints on these capacitors down here are not well made. There we are. See if there's any more I can spot. Sockets themselves look very nicely soldered, and of course that's the bit that sort of gets hot with the valve being plugged into it. The rest of it seems very nice indeed. So there we go. Quite a simple thing, isn't it, really? The money in this will of course be in the input and output transformers and quite a substantial power supply, and just been very nicely made. I mean, it's beautifully constructed, I must say. I do question some of this workmanship. I don't think this is original. I may be wrong, but it just looks a bit added on as an afterthought. There's even a chunk of solder hanging off that. Look at that. Just left stuck to the insulation. What were they thinking? Yeah, and these capacitors as well, they've been, looks like somebody's cut an existing capacitor out and put these Rubicons in. But yeah, it's not been very nicely done, but I'm not going to disturb it. I wonder what it was like when it left the factory. Again, this has been changed out for a black gate. Electron transfer. Well, don't they all? But yeah, I wonder if a bit of a snake oil salesman's been in here and upgraded the capacitors. There we are. Right. Yeah. So I think the next thing to do is to test these valves. That calls for breaking out the valve tester. Right. So I need to test the valves. So I have broken out Dozzy's Television Workshop's venerable AVO valve tester. Now this is quite clearly called a two-plate tester. They came in various different shapes and sizes. It was a nice little military one in a box, which was very good, but that was very similar, and they all perform the same task. Mine is a two-plate. It's had various bodges done to it over the years. You'll notice over here we have a selection switch, and this number in this sort of front half of the window here is the number we have to dial in from the data sheet. You can actually work it out because these are pins, so if you've got something that you're not quite sure of, you can work it out as you go. But we have the data for ECC 83, and the switch settings are 741 226, 741 226, and then 413, and I've got 234 in there. I don't know what I was testing last time. 413. So that should now be set for our ECC 83. There's only one socket it's going to fit in, and that's that one there. So then we've got other settings we need to do. We need to have there are two datas you can see in that sheet there. Data for valve characteristic type 100, and then data for AVO valve tester. So it's the data for the AVO valve tester we need. We need 150 volts anode voltage. So let's set that for 150. Milliamps per volt we need to set to 1.5. All the way around there. Okay, now because we've got, it's a double triode, there are two triode valves in there. We've got normal and anode 2. So we need to do that first. Heater voltage is set to 6 volts here. This is a stepped switch, it's not variable. So 6 is where we need to be. We don't want to be trying to get it halfway for 6.3 because that's just not going to work. Right, switch it on. Set 0. Let's just bring that up a bit. There we are. And as the valve warms, we should start to see some heaters in a moment. There we go. This will start to warm up. You can see that needle rising there. And when it stopped moving around, we will zero that back up. And we are looking for a figure of about 1.6 milliamps per volt. So, appears to be warm now, doesn't it? So let's zero that again. Touchy old girl, come on. Right, milliamps per volt. And that's sailing way over into the green section. So that's really very good indeed. I'm not going to worry about that at all. Yeah, it's like a new one, isn't it? So yeah. In fact, if we want to do milliamps per volt, what we do is we go down here, that's it. So that should read more than 1.6. Yeah, absolutely fine. So go to anode 2, measure again. Interesting, we're going negative. Why is that? Have we actually got a faulty valve? So when you set the milliamps per volt and you just go like that, it'll give you a go, no go. It's almost like that's not connected. Just going to check our settings again. 741 226 413. It's the second anode I'm worried about, which is pin 7. So let me just rotate that control back and forward just to make sure we're locked in position. I'm not getting any reading there at all. Might just have a rough socket. There we go, here we go. Zero that. Wants a bit of deoxide on it. Doesn't get used that often. Oh, there we go. It's going to be wonderful, isn't it? Let's just have a look at the milliamps per volt. Again, well over 2 there. And that one, yeah, absolutely nothing wrong with that tube at all. Just going to switch off. So that one is good. Repeat the process for this next one. Just wait for it to warm up again. It's important with this circuit, because it's clearly dealing with balanced audio, that both sides of the triode are fairly closely matched. Right, we appear to be somewhere near that one now. I'll just zero that out. Milliamps per volt. Oh, not so good. Not so good at all. What was our recommended milliamps per volt? Again, I can't remember. 1.5, yeah. So that tube is a little bit low on that anode. Oh, it's even worse on that side. Yeah. So we're getting a reading in the intermediate stage. It certainly isn't good. So yeah, I think that's not so good. Right, I'm just going to mark that with a green cross, so we know that that one isn't so clever. Interesting to see these are put in channels, so that's one channel and that's the other channel. Be interesting to see how the 6114s, whoa, these 6114s perform 6414, my bad. Right, let's find some data for the 6414 and test that the same. Okay, the 6414 data calls for, I think that's 641, 227. Yeah, the two anodes are reversed, look. 227 and 413 again. So let's just make sure we've got those switches absolutely aligned right. And 100 volts on the anode, and we're looking for 5.5 milliamps per volt. Right. Switch on, wait for it to warm. There we go, coming up now. Wait till that stops rising, it'll tell us when the tube is warm. There we go. Right, zero that. And test. That's looking good, isn't it? Well into the good there. So if we set this to milliamps per volt, measure milliamps per volt, minimum is 5.5 and we're at nearly 6. So that's good. Right, let's just move over to the other anode. Again, it's a double triode, this tube. Milliamps per volt, more than 5.5. Again, we set that for 5.5, that should be in the green, which it is. Okay, so that valve is okay. And let's run again. We'll wait for this other one to warm up. Okay, zero that. Swinging over into the green with a bit of luck. Beautiful. Try the other side. Nothing wrong with that one either. So we have got one low emission ECC83. Now really we want to be changing both of them as a pair, otherwise you'll get one channel that's slightly out of balance with the other. So the next thing I need to do is send a text message and get some valves on order.
1 week later.
Right, it's actually the following week. I had a word with Andy, the owner, and I've bought him a new valve, which is identical to the old one, and being as the other one read so good, I've got absolutely no problem with just fitting one. So there we go. Exactly the same 7025 WA 12AX7WA or ECC83. In fact, just looking at the date code, even there, very similar, so that's good news. So I'm just going to pop that into the holder. There we go, and I'm really not happy with this insulation showing on here, and it's all burnt and horrible up there. So I'm just going to sleeve some of that and make a better job of this aftermarket modification, because I'm really not very happy about the workmanship that's been deployed there. So yeah, let's just make some remedial work there. Honestly, it took longer to sort of repair this poor workmanship that would have done to get it right in the first place. But there we go, such is life. Right, it's all reassembled. I have here a CTP Systems DB Box 2. This is obsolete. It's now a DB Box 3. It's a really useful sort of Swiss Army knife of audio testing kit for the more professional environment. It's got balanced in and out. It does AES, XLRs, phantom power. It's got a lot. It does analog as well, and that's where we're going to be using it. So I've currently got it set in tone loop mode. It's got a little inbuilt speaker and even a little inbuilt microphone actually. And what I'm doing is I'm sending a signal out into the preamplifier here. And then we're coming back out of the preamplifier through a load of cable and back into the CTP box to complete a tone loop. And in fact, if I just connect these two leads together, there you go, you can see we've got a tone coming through there. So let's put the preamp back in. Switch on. That is now, it's currently outputting a microphone level. So we should be somewhere near. We'll just obviously have to wait for the valves to warm. And then we should hear some stuff coming through. We've got heaters. We have heaters. Ah, there we are. So there we go. Attenuator is working. Right, I'm just going to change channel. The CTP box will do stereo, I just don't have enough XLR leads to do it all in one hit, so we'll do it in two. Right. And there we go. It's good, the gain levels are about the same between the channels, as we sort of suspected. So that's good. Right, switch off. I wonder how long it stays up for. I mean, we've got a lot of smoothing capacitance there, haven't we? That's going to take going until the heaters go cold, no doubt. There it goes. So, yeah, I'm happy with that. And what I'm actually going to do now is, using this Tascam recorder, I'm going to connect its outputs into there, set this recording, switch it on, and then I'm going to leave it overnight. And in the morning I'll have a wave file, or several wave files I think. Not sure if it just goes for one or makes many, but anyway, we will have some wave files, and then I can put them in Audacity, and there's not going to be anything connected to the inputs, so I should just see quiet. There's going to be some noise from the preamp itself. But the complaint was every now and again it would pop and crackle. And if I leave it overnight, I can quickly look at those waveforms in Audacity and just check to see if they've, you know, any unpleasant fluctuations that we don't want to be seeing. So that is a way where I don't have to sit here and listen to it for hours on end. I can just leave it running overnight, come and review the waveforms in the morning, and yeah, hopefully it'll be good. Right, let's make that happen.
And there you have it. I'm happy to report that ran all night and the waveforms look great. There's no anomalies or anything going on in there. So yeah, happy that that's past muster now and it can return to Andy, its owner. Anyway, thank you very much for watching. Click like, subscribe, do all that rubbish, and I'll see you really soon here on Doz's Television Workshop. Cheers now. Bye.
With a gentle hand, he brings them back in line. Every twist and turn makes the magic shine. Cathodes and the crackle of the tubes amidst the dust. They play nostalgic tunes, solder smoke, and the faint aroma of time in each repair. An art that's so prime. Fix the picture, bring back color in the dark. Screens that buzz, it's magic on display. Old TVs revived in a brand new way. Circuit close, but we're getting closer. Neon signs, they guide you to the door. Tubes and screens like you've never seen before. Pulses hum as sparks begin to fly. In this tiny shop, dreams are set too high. In Doz's shop, with a touch of love, your picture's clear and true. In Doz's hands, pixels flicker back to life and stand. Microchips and vintage heart in a world of screens playing their parts. Circuit boards with stories to untangle. Every wire a promise as an angle. He bends the light through the lens, creating onyx nights. Oscillators creating sonic waves, bringing back the charm of retro days. Capacitors and resistors. In Doz's touch, there's no misfire. Transistors dance to the rhythm of repair. Through the glow, feels like magic fills the air. Voltage pulses, the tune's melodic run. A symphony of sparks, where the work is never done. In Doz's shop. With steady hands.
Benefit of everybody, it's Tascam 227 Radio Jackie.